Hi guys, welcome back. This is the second day of multi-step equations part 2. So this is going to be the lesson portion before you get to the practice, and this is kind of the one that brings it all together. So everything that Mr. Albert talked about with combining like terms, distribution property, and just basic two-step equations, we are now going to put them all together into one. So go ahead and take a look at my quote-unquote notes here for now. So there's a couple things we're going to try to piece together. So again, pause the video, slow things down if you need to, rewind for a second if that's going to help you out. So if we go back to pre-algebra, math 7, math 6 even, you guys end up doing a lot of order of operations kind of content. So something, for example, like this. Let's just go back real easy. Okay, so if I gave you a problem like that, we obviously start off with, well, should we start off with adding the 2 and the 4? Should we subtract the 4 and the 2? Should we multiply the 2 times 2? And figuring out which one we do first is what we call order of operations. And if you guys remember that sort of phrase that you may have used back then, is either PEMDAS, or if you're in other school districts, they use GEMDAS. Either one's fine. So we recall P stands for parentheses, E is for exponents, and for multiplication / division. So technically we should be grouping these two together. And then the A and the S together is addition subtraction. So the order in which we do things, we go from left to right. So if I see parentheses first, I will make sure I do parentheses. In our context over here, we do not see parentheses, so we're going to skip that. E is exponents, so on and so forth. Because we see multiplication division over here, we're going to multiply the 2 and the 2 first. Hopefully that rings a bell. When we talk about balancing equations, this is what I told my kids. Balancing equations is kind of like the opposite almost of order of operations. So we think of opposite, if we flip the entire PEMDAS around, we get something called SAD/MEP. It means we subtract and add terms first, then we divide and or multiply, then we do exponents, and then we do parentheses. We'll get to that in just a second here. The second component that we're also going to need is something called inverse, or let's just write it here, inverse or opposite operations. So take yourself back to first, second grade. If you have something that's added together, the opposite of that is going to be subtraction. If you're multiplying things together, the opposite operation or the inverse operation is division. And we can keep going from there. If I said, let's just say I have a variable called a. If I'm squaring the a, the opposite of that is square root of a. We're going to avoid this one for now, but I'm just going to throw it in there in case it helps out later down the road. These are what we call inverse or opposite reactions. If you see an addition, the opposite of adding is subtracting. If you see multiplication, the opposite of multiplying is dividing. That's going to help us out with our final example down here. Okay, pause the video, go back if you need to, just to take a quick set of notes there. By the way, shameless plug, I'm using OneNote right now, if that's something that would be helpful for you guys if you want to use that as scratch paper or a whiteboard. So over here, we've got a rather lengthy equation that we need to balance, and we're trying to figure out what the heck is x. What is the value of x? Is it 1? Is it -5? Is it 200? We don't know yet, and we're trying to solve for that. So here's the strategy I usually take when I'm dealing with this kind of problem. The first thing I'll ask myself is, isolate the equation, only work on the left-hand side. If you kind of imagine that this equal sign is sort of like the middle point, kind of like dividing the two sides, we have the left-hand side, and then we have the right-hand side. So I'm going to write it over here. Step 1, we're going to try to see if we can simplify the left-hand side. When we say simplify, we go back to the first lesson Mr. Albert did, and we talk about the two components that were very important. We talk about the combining like terms, and we also talk about distributive property or distribution. So let's take a look at the left-hand side. Let me change colors back to green to match the green highlighting here. Is there anything we do with this distribution or with combining like terms? This is where PEMDAS comes into play. We're dealing with this left expression here. There's no equation sign, so we're dealing with PEMDAS. Let's look for parentheses. I see parentheses here. X minus 2. Wait, I can't really combine those two. They're not the same thing. All right, E, exponents. No exponents. Perfect. MD, multiplication and division. I notice here that there's a multiplication between the 3 and the parentheses. This is where we do the distributive property. As I tell my students, and some of you may have heard of this is what we call it the Mr. Ghosty face. We're going to multiply the 3 to each of the terms on the inside. So we get 3 times x, which we can't do. We don't know what that's going to be. We leave it alone. And then 3 times the negative 2. Remember that minus sign is combined with a 2. Anything on the left of that number or variable is going to be attached to it. So it's going to be minus 6. I'm going to bring down that plus 2x from above, and then we continue from there. Now that we've done distributive property, can we combine like terms? So let's look back on the left-hand side here. I see a 3x here. Are there any other x's to see? Yeah, I do. I see a plus 2x. 3x plus 2x. Oh, that's just going to be 5x. The minus 6 right here is just going to bring it on down because we did nothing with it. And now the left-hand side is complete. So here's what I'm going to do now. I'm going to bring back the rest of the equation from where I left it originally up here. Bring it back down, equals this ridiculousness that goes on here. So now we deal with simplifying the right-hand side. So again, we started with the left-hand side. Now we're going to do the right-hand side, and then you can probably guess what the third step is going to be now that both are simplified. So let's do the second step. Right-hand side, can we distribute? Can we combine like terms? We take a look here. Let's take a look at the top. The x plus 3, can't really combine that. There's a whole thing divided by 2. Can't really do much with that right now. So we're going to say that the right-hand side is as simple as it can possibly be. And so now comes the third step, where now we're going to use, instead of PEMDAS, we're now going to use the SADMEP to help us out. Opposite operations. They're kind of similar things together. So if we take a look here, we notice that the first thing that we probably want to do is add or subtract things over. Now, this is where I'm going to throw it in because this is one of those like tricky scenarios where you may actually not want to add or subtract things over on this side. What I'm going to actually start doing is, a lot of you guys kind of have this sort of forethought where it's like, ooh, this is a fraction. It's this top thing divided by the 5. I'm not a huge fan of that. A lot of you guys may say that. And so let's talk about the first thing. Can we get rid of fractions? This whole thing is being divided by 2. If we use our opposite operations, what's the opposite of dividing by 2? Oh, well, that's easy. Multiply by 2. If I multiply this whole thing by 2, as well as the left-hand side, multiply that whole thing by 2, we're being fairly equal to both sides. What I do to one side of the equation, I'm going to do to the other side. It's what I call the golden rule of algebra. So once I get that, these 2's will cancel out, leaving us with x plus 3 on the right-hand side. We got rid of the fraction. Awesome. On the left-hand side here, wait, this kind of looks like what we just had way up here at the beginning. We multiply everything on the inside there by 2, or if you want to use Mr. Ghosty Face, we're distributing the 2 to each component. So we did 2 times 5, it's going to be 10x. 2 times negative 6, that's going to be negative 12. Again, pause the video, slow it down if you need to. And now we're at the final home stretch here. This is basically what we were doing on the first day of part 2, where we're now balancing the equation. Let's apply a SADMEP to this now. So, add or subtract. Well, I see that I have my x's. I'm going to focus on those real quick. Let's get my x's on the same side. I have 10x on this side. I have 1x on this side. What I can do is I'm going to say, hey, I already have 10 x's on the left-hand side. Can I get this x thrown over to the other side? You can, but you need to follow some rules. It's a positive x. There's an implied positive x in front of it. Oh, if it's a positive x, well, I can do the opposite, which is subtracting the x. I'm going to subtract the x to both sides. Let me draw that bar down so that we know what it means by the other side. The equal sign is sort of our honing point. Okay, let's take a look. When we have x minus x, anything subtracted by itself is going to cancel out. 1 minus 1 is 0. 10 minus 10 is 0. A million minus a million is 0. Then we look on the left-hand side. 10x minus 1x, that leaves us with 9x's. Let me change the color there so that it's actually matching. It's going to be 9x's. So now the right-hand side, there are no more x's, but we still have this 3 we're going to bring down. It's going to be a positive 3 here. We have this negative 12 I'm going to bring down, so minus 12, and I'm going to keep bringing that equal sign down. Are we getting a simpler solution? Yes, we are. All my x's are now on one side of the equation. We're balancing things out. So last thing here, or not last thing, sorry, last thing with addition subtraction. We have this minus 12 that I might want to throw to the other side because my goal is to get the x. I want to get this x alone. This minus 12 is pretty pesky. It's getting a little annoying to us. So if it's a minus 12, think opposite operation, inverse operation is going to be plus 12. I'm going to add 12 to both sides. Negative 12 plus 12, well, that's nice. They cancel out. Anything minus itself or opposite of itself will cancel out. And now we have 3 plus to 12. 3 plus 12 is going to be 15. Bring the equal sign down. That 9x didn't do anything, so let's just bring it down. We get 9x equals 15. We're getting closer and closer. Now let's see, can we add or subtract anything? I don't see anything added. This is a 9 times x, that's a positive 15, but there's no two terms being added or subtracted. So now we move on to divide and multiply. I see there's a times here. 9 times x. But I want to get rid of the 9. I don't want to get rid of the x. X I want to leave alone. I want to get x by itself. So because it's 9 times x, I can actually do divide by 9 to both sides. What will happen is now the 9s, when we have a 9 divided by 9, anything divided by itself, 2 divided by 2, 10 divided by 10, negative 5,000 over negative 5,000. All these numbers divided by themselves gives us 1, which means x is by itself. 1x and x are the exact same thing. And so finally, last resort, and this is, I want to throw this in there because I know some of you guys had some issues with this. 15 over 9, how can I do that? For one, if you have decimals, you can definitely plug that in there. But me being the math teacher that I am, I actually like keeping things as fractions. I actually like the way they look better than decimals, and sometimes they're actually more accurate. But that's aside from the point. I'm going to leave this as 15 over 9. And you can convert that into a decimal using decimals if you'd like. Simplifying fractions, however, we can also get this down, dividing both the top and bottom by 3. We get 5 over 3, both being the same thing. And so if I were to convert this to a decimal, this would be approximately 1.66 repeating, so 1.66666, so on and so forth. And yes, it is possible that you get decimal answers sometimes. That is math. It's not going to always be pretty. But I'm going to use my fraction answer because I prefer that. But that is one way of answering the question here. Try the practice out. Give it a shot. They won't be as difficult as this problem, but I wanted to use this as a good example of kind of highlighting a lot of different pitfalls and different issues you may see coming up. Hope that helps out.